Imagine a world without roads, just dirt trails, muddy tracks, and endless fields. Traveling even 10 kilometers could take an entire day. Now, think about today. We can drive hundreds of kilometers in a few hours on smooth highways that connect cities, countries, and even continents. But here's the secret. A road isn't just a strip of black asphalt. It's a carefully engineered system, layered, designed, and constantly evolving. Today, we're going to uncover the incredible journey of roads, from simple dirt paths to futuristic smart highways. The first roads. Let's rewind thousands of years. The very first roads were not built. They were formed naturally. When people and animals walked the same path repeatedly, the ground became compacted. These dirt trails connected villages, markets, and rivers. But they had problems. When it rained, they turned into mud. When it was dry, dust choked travelers. The first real breakthrough came from the Romans. Over 2,000 years ago, the Roman Empire built an enormous network of roads, some of which still survive today. Their secret was engineering. Roman roads weren't just flat stones laid on the ground. They had layers, large stones at the bottom, smaller stones and gravel in the middle, and tightly fitted paving stones on top. They even built roads with a slight curve called a camber, so rainwater would drain to the sides. This design made them incredibly durable. In fact, many modern highways follow the same routes that Romans mapped out. The birth of modern roads. Fast forward to the 18th and 19th centuries. Travel was exploding. Carts, horses, and eventually automobiles needed better roads. Two engineers revolutionized road design, John Loudon Macadam and Thomas Telford. Macadam invented macadam roads, where small stones were compacted tightly together, making a smoother surface. Later, tar was added to reduce dust, giving us tarmac. That's right, every time you say tarmac, you're actually honoring an engineer from 200 years ago. Meanwhile, Telford focused on road foundations, raising them higher than the surrounding land to avoid flooding. Both innovations laid the groundwork, literally, for modern highways. Anatomy of a modern road. Now let's zoom into a modern road. If you could cut it in half, like slicing a cake, you'd see it has layers. Each layer has a job. Subgrade. This is the natural soil underneath. Engineers test it carefully because weak soil can't handle heavy traffic. Sometimes they add sand or geotextiles to strengthen it. Subbase and base course. These are layers of crushed stone and gravel. They spread the weight of vehicles and allow water to drain away. Binder course. This is a mix of bitumen and aggregate. This layer binds everything together. Surface course. This is the top layer, usually asphalt or concrete. It's what tires touch, and it's designed for grip, durability, and smoothness. And here's the genius. Roads aren't perfectly flat. They have a crown or slope, so rainwater flows off quickly. Without this, potholes would form in days. Challenges in road engineering. But building a road isn't as simple as stacking layers. Engineers face challenges every day. Traffic load. Highways carry thousands of vehicles daily, including massive trucks. Each truck can put as much stress on a road as thousands of cars. That's why highways are built thicker and stronger. Weather. In hot regions, asphalt can soften and deform. In cold areas, water seeps into cracks, freezes, expands, and creates potholes. Engineers design roads differently for deserts, mountains, and icy regions. Safety. Roads aren't just for cars. They must keep humans safe. Guardrails, rumble strips, reflective paint, and signage are all part of road engineering. Even the angle of curves is calculated so vehicles can turn without skidding. Highways, the arteries of civilization. Think of highways as the arteries of a nation. They don't just connect cities, they power economies. The US interstate system, Germany's Autobahn, and China's expressways transformed how people live and trade. But behind every kilometer lies complex planning. Engineers must acquire land, design intersections, ensure drainage, and calculate traffic flow decades into the future. Ever notice how highways have gentle slopes instead of steep climbs? That's not an accident. Engineers design gradients to balance fuel efficiency, safety, and construction cost. The future, smart highways. Now comes the exciting part, the future of roads. Engineers aren't just making roads stronger, they're making them smarter. Solar roads. Some countries are experimenting with embedding solar panels into road surfaces, generating clean energy as cars drive over them. Glow-in-the-dark markings. In the Netherlands, highways use special paint that absorbs sunlight during the day and glows at night, reducing the need for streetlights. Inductive charging lanes. Imagine driving an electric car that charges while you move. Pilot projects in Sweden and South Korea are already testing this. Self-healing asphalt. Special capsules mixed into asphalt release materials that fill small cracks automatically, extending road life. AI traffic monitoring. Cameras and sensors embedded in roads can track traffic, warn of accidents, and even communicate with self-driving cars. These ideas sound futuristic, but many are already being tested today. Hidden heroes of road maintenance. Of course, building roads is only half the battle. Maintaining them is equally important. Road crews patch potholes, resurface old pavements, and keep markings visible. Recycling is also becoming common. Old asphalt is crushed and reused to make new roads. This saves money and reduces environmental impact. Some countries even mix plastic waste into roads, turning trash into a durable surface. India, for example, has thousands of kilometers of plastic roads that are stronger and more resistant to water damage. Real-world wonders. Let's look at some amazing examples around the world. Netherlands smart highways, using glow-in-the-dark paint and dynamic weather-responsive road signs. India's plastic roads, turning waste into stronger highways. China's solar expressway, a 2-kilometer stretch that generates electricity for streetlights and signs. Germany's Autobahn, famous for sections with no speed limits but built with extremely high engineering standards. Each of these examples shows that roads aren't just boring gray surfaces, they're platforms for innovation. Beyond roads, the human impact. Roads don't just move cars, they shape lives. A new highway can connect isolated villages to cities, hospitals, and markets. Roads bring trade, opportunities, and education, but they can also cut through forests, displace communities, and harm the environment. That's why modern engineers are tasked with balancing progress and sustainability. So, from dirt paths carved by footsteps, to Roman stone highways, to glowing smart roads of the future, the journey of roads is the story of civilization itself. Every time you drive, remember, under your tires lies thousands of years of engineering wisdom, endless challenges solved, and a future still being paved. Because roads are more than just ways to get from A to B. Roads are the foundation of human progress. Thanks for watching, and next time you hit the road, look closer. You might just see the hidden engineering beneath your wheels.